Hi there, my name is Bruno and I'm a lecturer at Maynooth University. Today, I want to talk to you about a workshop in Big Data and Machine Learning that I'll be giving in the second term. This workshop will be open to all postgraduate students in economics, and the learning outcomes are the one listed in these slides. At the end of this workshop, that presumably will consist in 4 seminars of about 1 hour, you'll be able to master the jargon of big data and machine learning, as well as understand and critically assess economic output, be that research or policy papers that leverage these methodologies. Thanks to this, you will be aware of the main contribution and trends in the so-called data-rich research, and you'll also be able to build the basis to use big data and machine learning for your own projects. But why should you bother about big data and machine learning? Well, the answer is in this graph. As you can see, in the last 20 years, the number of economic papers using these techniques has grown exponentially. Thanks to new technologies and to the availability of new datasets, indeed, more and more papers are using so-called research-intensive methods to make their point. So it doesn't really matter which field you are from and whether you actually plan to use these methodologies yourself, you will need a strong basis to at least understand what these papers that might be relevant for your own research are doing. In particular, I really want you to be able to go beyond the buzzwords of big data and machine learning. And I will do so by providing you with consistent and useful definitions and a sound understanding of the trade-offs between the use of big data and standard data sources used in economics, as well as by comparing the characteristics of machine learning to the classical statistical inference methods. I want just to give you a rough idea of the types of data we'll be looking at during the course. And as you will see, big data actually is a very, very big term that contains a number of very, very different data sets. In this slide, we can see some mobility data that were derived from the use of apps in mobile phones of users in Europe and in the US, and were used to study how much mobility was reduced, by how much the mobility was reduced as a result of the COVID-19 pandemic. Another application of big data is the one that the Central Bank of Ireland provides with real-time data on the use of ATM machines in Ireland. And here we can see how, as a result, again, of the COVID-19 pandemic and the restrictions introduced in January, there has been a sudden and big drop in the amount of cash retired in ATM machine. Again, all of this very rich information is only possible by the use of big data, as opposed to traditional economic data. Another very famous application, perhaps the first one to make the headline, was the Policy Uncertainty Index that was based on a text analysis of the major US newspapers that allowed to create an unique index able to capture the level of uncertainty in economic policies experienced by the US at every single day. Going a bit closer to home, another example of big data is the collection of prices observed in a virtual marketplace, in this case daft.ie, that allows us to see the evolution, the real-time evolution in property prices across the different counties in Ireland. Just to give you a rough idea instead about what machine learning does and what the main difference with respect to statistical difference is, the main trade-off is that machine learning uses way more data but does not impose any structure. So whenever we will talk about machine learning models, we're talking about models that don't make any a priori assumption on how two or more variables are related, but rather let the data speak. And by doing so, typically, we're able to predict outcomes at a very, very accurate level. In this case, we can see a very typical application of machine learning, that is to say, the prediction of monthly energy consumption of a household depending on a number of different variables. And we can see how machine learning performs really, really well in this sort of tasks. But this has also been applied to macro variables such as GDP. In this slide, we can see the performance of a machine learning model in predicting the GDP growth in the UK. And we can see how the predictions that are obtained this way are even more precise than the one obtained with some standard statistical model. So a really powerful tool that we need to learn at least to understand. I've used big data quite profusely in my own research. For example, I used tax data from all of South African registered workers to study the welfare impact of some trade policies that were enacted by the country. Also used narrow grids of spatial data to study the deviations from optimal crop distribution in Uganda, and more recently used Facebook data on apps use to study mobility changes in Mexico during the COVID-19 pandemic. Therefore, I have my own experience in this field, and I would be very, very glad to discuss your projects in case you think that would be useful for you. So, to sum up, I'm really looking forward to hearing from you, and you're very welcome to contact me at bruno.morando@mu.ie for any questions on these seminars. Thank you very much.